Mr. Newton, are you not going to be teaching us about variance and standard deviation via flipped learning?
Not this week, I'm afraid, Dr. Young, but you're going to stick with the same style of note sheet.
If only one of us was at home, we could still be using this note sheet to follow the video along via flipped learning.
Yeah, exactly. Now, let's get going. Epic pan, might cut that bit, epic pan. There we go. Right, okay, so we've been looking at spread, okay, and we looked at interquartile range, and that was great, but we're going to have a look at something else now, and this is like a set of data, doesn't matter what it is, and these are our x values, okay, and what we're going to do, we're going to find, first of all, the mean, okay. Now, I did this earlier very quickly. If I want to find the mean, x bar, I want to do the sum of x divided by the number of items that are there. Okay, so that's going to be hopefully 20, added that up really quickly, divided by how many things? 5, which gives me an x bar of 4. Okay, we know the mean, we used to calculate that, we've done it with other things as well. Now what I'm going to do, I'm going to think about how spread out this is, and I'm going to work out the distance away from the mean. And how I'm going to do that is by just doing a subtraction. I'm just going to take all the x values and take off the mean. Okay. So if I start with x is 1 and take off the mean, I'm going to get -3. And I can keep going and do it for the rest of them really, really quickly. Okay. Now you probably notice if you added them up, you get 0. Okay. And that's because some things are above the mean, some things below the mean. It'll balance out that they're all at the mean. Okay. Now there's two ways to go from here, and one way kind of makes sense, but isn't the way we're going to go. Okay. We're going to have a look at the actual distance away from the mean. So that was -3, that difference. So we're just going to say it's 3 away. This one's 2 away, 1 away, 2 away, 2 away. And what you could say, well, I could work out the average distance away by adding them up and dividing by how many. And if you add them up, you get 10, divide by 5, you get 2. So we can say the average distance away from the mean is 2. Okay? But we're not going to use that measure. We're going to go for something else. And someone very smartly said, well, to get rid of these negatives here, we're going to square this. So I'm writing it down, just like that. I'm going to square each one of these. 9, we get 4, 1, 4, and 4. Okay? Right, so we've squared the distance away from the mean. Okay. And what we could do then, we could say, well, let's find this square distance and find like average of that and divide by how many things there are. So I'm going to add these up. Divide by how many things. Now if I add them up, Doctor, are you working through this in your note sheet as we speak?
Mr. Newton, yes.
Brilliant. What did you get when you added these up?
22.
22. Well done, Steve, you've done that very well.
Thank you.
And we're still dividing by 5, hopefully. So does that give me 4.47?
It does.
Okay, so someone said, well, this is a great way of working out a kind of measure of kind of an average-ish, generally distance from a mean. And they called it something specific. They called this the variance. Okay, so this formula here is what we call the variance. All right.
What was that name again?
The variance. Well done, Mr. Barker. I wasn't paying attention. Now, if we want to go a little bit further with this, we might call this a little sigma here. Squared. Well, your sigma squared is the variance. And we might write this formula down here. I bet you'll be able to fill that in on your note sheet. Okay. Now, obviously we've done a lot of squaring here, so we might need to undo this by square rooting. So we square root that to get something that we call the standard deviation. Which in this case, when I tell it in my calculator, Dr. Young, but I would get
2.097617696.
Yeah, so should we go for 3 significant figures?
2.10.
2.10. Okay. Now obviously I think what I'd do, I'd write it down to a few more decimal places first. Have you got any questions, guys?
If I did have any questions, I could write it down on my note sheet under the question part, and then I could bring it into class to ask Sir.
Right, okay, so we've just had a look at basically where standard deviation and variance come from, and I've got the formula that we came up with for variance. And you can see it was a bit of a hassle to use that because we had to find the difference between each x value. So you can actually show that this is equivalent to this formula here. Notice I'm using sigma squared for the variance. To find standard deviation, add square root. And what you can change it is the sum of x squared divided by n, take away the sum of x over n, all squared. Okay? Now, this formula is much easier to use, so we're going to stick with that one. Okay? Sometimes I like to remember it in words, and say the mean of the squares, so the sum of x squared divided by how many, it's kind of like the mean of the squares, take away the square of the mean. Sum of x over how many, sum of x over n, is the mean, and I've squared that. Okay, so let's go ahead and use this formula here. Right, I'm going to write it down just at the bottom here so I can see what I'm using. This is the variance, sigma squared, equals sum of x squared divided by n, mean of the squares, take away the square of the mean. There's the mean. Let's square that mother there. Okay. Now, these are my x values for this data. And we've got to find variance standard deviation. So when we first thing we want to work out, I need the sum of x squared, I need the sum of x. Well, I'm just going to do a little x squared row. Okay, and it's nice and easy. I can just square numbers. If they were harder numbers, which you could get, you could use a calculator. Okay. Okay, now I can quickly get on my calculator, I can work out the sum of x. That's if I add up all these x values here, and I get 36. Okay. If I work out the sum of x squared, I just add up these values here in this row, they're all the squared values, and I get 218. Now I'm going to plug everything into my formula here, so I'll get sigma squared equals sum of x squared, that's there, 218. Divide by how many? Oh, hang on a minute, we haven't worked that out. 1, 2, 3, 4, 5, 6, 7. Divide by 7. Minus, put the brackets there. Sum of x, 36. Divided by 7. And don't forget to square it, that's a common mistake there. Right, now I'll put this in my calculator, and it comes out with some massively long number like 4.69, blah blah blah. And I've rounded that to 3 sig figs, 4.69. But if I'm going to then square root it, I'll keep that answer on my calculator so I don't lose any accuracy. Okay. So then I square root it, I get sigma, the standard deviation, and I get 2.16, blah 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 on my calculator. So I'm going to round that, after I've written it down, 2.17 to 3 sig figs. Okay. Please don't forget to square root, that's a very common mistake. Okay? I think that's everything you need to know.
Right, let's have a look at example 2. So in this example we have a frequency table. So this means that we have 3 pieces of data, each that are 35. So we're going to use the following formula. Now this says that the variance is equal to the sum of f of x squared divided by the sum of f minus the sum of f of x divided by the sum of f all squared. So this is the same formula we looked at earlier, but this time we have to multiply by the frequency. So you can see that I've added 3 extra columns. That's what you should do on your sheet as well. And the first one I'm going to label x squared. The next one is going to be f times x, and the last one is going to be f times x squared. So, first step, let's square x. Well, if x is 35, we all know that 35 squared is 1225. Easy. So the next column, we need to do f, our frequency, times 35. That's what these 3 pieces of data are contributing. 3 lots of 35 is 105. Now we've got 3 lots of 35 squared. Well, this is just f times x squared. 3 lots of 1225 which is 3,675. Right, what you should do now is pause the video and fill the rest of these in. I'm going to do it really quickly. Right, hopefully your table resembles this. I suggest you pause the video again and just check that all your entries are exactly the same. Right, so remember, this is the same formula as what we've looked at before, but this time we're having to multiply by the frequency before we add them up. So you can see that I've put some total columns, totals at the end of each row. And we've got that we want to take the sum of fx squared, well that's just this number here. So 154,050. And we also want the sum of f of x. So that is 4,096. And the last one we want is the sum of f, which is 109. So let's put this into our formula for the variance. So we've got the variance, or sigma squared, is equal to the sum of fx squared, so that's 154,050, divided by the sum of f, or how many pieces of data we have, that's 109, minus the sum of f of x, that's 4,096, again divided by 109. But remember, we have to square this. So then we reach for our calculator, put that in, and we get 1.19805. So that is our answer for the variance. So to get the standard deviation, we square root this, and remember we can denote standard deviation as sigma. That's going to be the square root of 1.19805, which comes out to 2 decimal places as 1.09.
Okay, so for example 3, obviously the difference is we've now got grouped data, and just like when you were estimating the mean, to make an estimate for the variance and standard deviation, we're going to need the midpoint. So our first column is midpoint, which is x. And then from there it very much follows on. So we're going to have to get x squared, we're going to need f times x, and we're going to need f times x squared. So that's the 4 additional columns that we need. And from there it's fairly straightforward. Obviously for the first group we're from 0 to 5, so the midpoint would be 2.5. And then we're going to square that. When we do 2.5 squared, we all obviously know that's 6.25. And then f times x, so the frequency 4 times the midpoint 2.5, that gives me 10. And f times x squared, well it's still 4, and x squared is 6.25, and obviously 4 lots of 6.25 is just 25. Right, I'm going to go ahead and fill the rest of this out. You might want to take a second and pause and fill it out for yourself too. Done. So hopefully your table matches mine, and you'll notice here how I've added a row for totals under the frequency column, f times x and f times x squared, because obviously we're still going to need those totals. So if we want to work out the variance first, well, I'm going to need the sum of f times x squared, and I've added them up to be 6,487.5. We're going to need the sum of fx, that's totaled up here as 285, and then I'm going to need the sum of the frequencies. So sum of f is 27, and I can start working out my variance. So following the formula, I've got the variance is equal to the sum of f squared, so 6,487.5 divided by the sum of f over 27. Take away the sum of f of x, that's 285, divided by the sum of f, 27 still, and obviously that value is squared. Alright, so when I crunch those numbers, that's going to give me 128.85802 off the top of my head, and that is my value for the variance. Now obviously for the standard deviation, I'm going to square root that. So the standard deviation equals the square root of 128.85802, which is equal to 11.35 to 2 decimal places. So that's my variance and standard deviation from a grouped frequency table.
No, you have literally effed it, Mr. Barker. Look, f of x, you've effed it.
Effed it right up.
I've really effed that. I've effed that up good.
Well, that bit there.
Yeah.
Yeah, because it should be fx.
Yeah, not f of x.
You've effed that. You shouldn't
I've
have effed
really
it.
effed that.
Yeah, it's just f times x. You've effed it.
Effed that right up.
What?
Dr. Young,
Let's pan this around.
isn't that meant to be sigma squared? What have you put? I don't know, so what did you put? That's almost as bad as putting m for quartile 1.
Well, at least you didn't F it though, hey?